Hello everyone, welcome to another session of matrix algebra for statistics and econometrics. Today we're going to have a look at a very simple operation called axpy operation, axpy operation. Right now, if you are someone who have done linear equations earlier on in your study life, this is very simple. Suppose you have a linear equation of z is equal to ax plus y. Simply means that a is a number, right? And then which is a constant, obviously I like to say constant. And then you have different values for x and y. The number changes, and depending on this number changes, you get different values for z as well, right? So this is the basic your linear equation. In axpy is very simple. It's very similar as of a linear equation. What we do here is that we replace this a with a vector and with y also a vector, right? So the important thing about axpy operation is that you still follow the same procedure. So the first, you multiply a real number by your vector, or you can say this is your scalar, right? Multiply it by the vector, then add it by the next vector, y vector, and then you get result also is a vector, right? So let's have a look at an example here. Suppose you have x vector that is 2, 3, 4, and you got a is equal to, let's say, 5, and then y is equal to 5 to 1. Remember, there needs to be of the same, they need to have same number of elements. 2, 3, 4, 3 elements here, and 5 to 1, 3 elements here, okay? This is scalar, that's why it's just one number. And then, what you do, you have your 5 to get your z vector. You take your 5, multiply it by 2, 3, 4, and then add it by the vector y, which is 5 to 1, right? Which gives you the z vector 5 times 2, 10, 15, 20, right? Plus 5 to 1. Now it's just a simple vector addition. 10 plus 5, 15, 15 plus 2 is 17, and 20 plus 1 is 21. Here you go. This is your answer. So you've successfully done the axpy operation. Remember, it is a just like if you know the in linear equation, just remember that format. And instead of the constant remains the constant, a is a, but then x becomes a vector and y also becomes a vector. So the resultant, what you get, z, is also a vector, right? Important to keep in mind is that you follow this procedure, okay? You first always multiply the scalar with your x vector and then add up with the vector to get the resulting vector z. Now, why is it called axpy? Just see a similarity here. A is a constant here, so this a is this a here, right? And x vector is x here, plus for p, and then y for y here. So that's why it is actually called axpy operation. Well, I hope that has been helpful. Thank you very much. See you later.